this is some simple numerical that you can easily solve it. Now you can see this matrix is in row echelon form. This is our leading entry. Below that leading entry in that particular column we have already 0. This is our leading entry in the second row. Below that leading entry we have 0, and in the third row this is our leading entry, right? So this matrix is in row echelon form. It satisfied all the conditions to become a row echelon form. So now we can easily solve these equations from this row echelon form augmented matrix. X plus y plus 2z is equal to 9, 2y minus 7z, that is equal to minus 17, and then minus 1 by 2 into z, that is equal to minus 3 by 2. So z is equal to 3. From this third equations you will get z is equal to 3. Put z is equal to 3 in the second equations. Put z is equal to 3 in the second equations. What is our second equations? 2y minus 21, right? 2y minus 7 into 3, right? Because z is equal to 3 now. So 2y minus 21, that is equal to minus 17. So 2y is equal to 4 and y is equal to 2. Now substituting y is equal to 2 and z is equal to 3 in the first equation, we get x plus 2 plus 6 is equal to 9. X plus 2 plus 6 is equal to 9, right? Put in the first equation x plus 2 plus 6 is equal to 9. So we will get x is equal to 1. Thus the solution is x, y, z is equal to 1, 2, 3. Okay. Now question 1b, second part. Find the rank of the matrix. Here is our matrix 3 cross 3. This question was asked in 2 marks. Again we have to convert this matrix into a row echelon form matrix, right? And whatever the number of non-zero row in the given row echelon form matrix, that is exactly the rank of the given matrix. Okay, that is the definition for the rank of the matrix, that we have to convert the given matrix into a row echelon form, and how many number of non-zero row, that is exactly the rank of the matrix. Okay, so this question was quite easy. Now you already know that how to convert a matrix into a row echelon form. So this is our matrix 1 2 3 okay, this is our matrix 1 2 3 4 5 6 7 8 9, correct? Now we are multiplying first row with minus 4 and add into the second row. You will get 1 2 3 as it is, first row is as it is, second row becomes 0. 5 minus 2 into 4, that is 5 minus 8, that is minus 3. Then 6 minus 3 into 4, so 6 minus 12, that is minus 6. Then 7 minus 1 into 7, that is 0. Then 8 minus 2 into 7, so 8 minus 14, that is minus 6. And then 9 minus 3 into 7, that is 9 minus 21, you will get minus 12. Okay, now you can see the second row. Now this is our leading entry, below the leading entry we have 0. Now in second row this is our leading entry and we won't make 0 here, right? So that's why we multiply second row with minus 2 and add into the third row. Okay, we are multiplying, so just write down here r23 minus 2. Okay, so that was missing here, r23 minus 2. So the first and second row are as it is, 1 2 3, and the second row, and then second row we are multiplying with minus 1 by 3. So that's why you will get 0 1 2. You can see the second and third row are linearly dependent. Clear? See, this is minus 3. When you take minus 3 with multiplying with 2, you will get minus 6, and minus 6 into 2 minus 12. So when you multiply second row with minus 2 and add into the third row becomes 0, and then the second row become when we multiply second row with minus 1 by 3, you will get 0 1 by 0 1 2. Okay, now this is our row echelon form matrix. You can see how many number of non-zero row in this matrix, 2. So the rank of matrix is 2. Okay, and this question was asked is also in the 2 marks. Okay, so this is a question 1b second part. The next is question 1 C. Question 1C, first part. Find the inverse of the matrix 1 0 1, minus 1 1 1 and 0 1 0 using row operations. So this question was asked in 3 marks. This is the given matrix 1 0 1, minus 1 1 1, 0 1 0. This is row echelon form matrix. This is identity matrix. The right hand side we are written here identity matrix 1 0 0, 0 1 0, 0 0 1. Okay. Now what we have to do here, we are converting we are using here row operations, and then we want identity matrix is in left hand side, right, and whatever the right hand side matrix, that is exactly the inverse of the given matrix. So here we are using some row operations. Using that row operations we are converting, we will make a left hand side matrix is exactly the identity matrix, and whatever the right hand side matrix, that is exactly the inverse of the given matrix. Okay, so let's start. This is a given matrix. The left hand side, the first step is A oblique I, that means I is identity matrix. So the left hand side we are written here matrix A, and the right hand side here 1 0 0, 0 1 0, 0 0 1, that is identity matrix. Okay, so now using some row operations, here we are multiplying first row with 1 and add into the second row, right. So this is our leading entry. Below that leading entry we want 0 here. So here already 0, but here we want to 0. So that's why we are multiplying first row with 1 and add into the second row. So the second row is 1 0 1, 1 0 1. The first row is as it is 1 0 1, 1 0 0. The second row become 0. You can see we are multiplying first row with 1 and add into the second row. The second row becomes 0, then 1 plus 0 1, then 1 plus 1 2, then here 0 plus 1 1, 1 plus 0 1 and 0 plus 0 0. So this is the second row 0 1 2 1 1 0. Third row is as it is. Now this is our leading entry. Below that leading entry we are already 0 in that particular column. Now in the second row, pick up the second row. This is our leading entry 1. Below that leading entry we want to make 0 here, right. So that's why we are multiplying second row with minus 1 and add into the third row. So the first and second row are as it is 1 0 1, 1 0 0, 0 1 2, 1 1 0. The third row become 1 minus 0 minus 0 0, 1 minus 1 0, 0 minus 2 minus 2, 0 minus 1 minus 1, 0 minus 1 minus 1 here, and 1 minus 0 1, right. Now next process is in the third row. This is our leading entry. We want make here 1 first of all, right. So that's why we are multiplying third row with minus 1 by 2. So that's why we are converting this element from minus 2 to 1. Okay, so we are multiplying third row with minus 1 by 2. So the third row is 0 0 1, 1 by 2, minus 1 into minus 1 by 2, so that is 1 by 2, minus 1 into minus 1 by 2, that is 1 by 2, and 1 into minus 1 by 2, that is minus 1 by 2. Okay, so the third row becomes 0 0 1, 1 by 2, 1 by 2, minus 1 by 2. Other all elements are same as it is. The first and second row are as it is. Now what will be the next process? You can see this is third row, this is our leading entry. Now above that leading entry we want to make 0 here, right. So that's why we are multiplying third row with minus 2 and add into the second row, and third row with multiplying with minus 1 and add into the first row. So the third row is as it is. The second row, the second and first row, in second and first row you can see the left hand side now is exactly the identity matrix, because when we multiplying third row with minus 1 and add into the second row becomes 0 1 0, correct, and the third row first row become 1 0 0. So the left hand side is now exactly, so this will be the last process. This will be the last process. We are multiplying the third row with minus 2 and add into the second row, and multiplying third row with minus 1 and add into the first row. Okay, so this will be the last process. The left hand side is now we have identity matrix. Whatever the right hand side, that is exactly our inverse. So let's see, whatever the right hand side matrix, we are multiplying third row. What is the process? We are multiplying third row with minus 1 by 2 and add into the we are multiplying third row with minus 2 and add into the second row. So the second row become, you can see 1 minus 2 into 1 by 2, so that is 1 minus 1 0, right. Then again 1 minus 2 into 1 by 2, so that is 1 minus 1 0, you can see this is 0. Then 0 minus 2 into minus 1 by 2, so that will become 0 plus 1, so here 1. So the second row here 0 0 1, you can see the left hand side is exactly identity matrix, right. Now we are multiplying third row with minus 1 and add into the first row, so this will become 1 minus 1 by 2 1 by 2, 0 minus 1 by 2 minus 1 by 2, and 0 minus 1 by 2, that is 1 by 2. So 1 by 2 minus 1 by 2 1 by 2, 1 by 2 minus 1 by 2 1 by 2. So this is our inverse of the given matrix A, exactly, right. The left hand side is this is identity matrix, and this is exactly the inverse of the given matrix A. You can see this is equal to I oblique A inverse. So this is A inverse. A inverse is equal to 1 by 2 minus 1 by 2 1 by 2. This is 0 0 1, and this is 1 by 2 1 by 2 minus 1 by 2 1 by 2. You can take as a common element from the first and right, as a common element, so from all the rows, so you will get 1 by 2 will be common. So 1 minus 1 1 0 0, you are using 1 by 2 as a common, so this element become 2, and then 1 1 minus 1. Okay, so this is exactly the inverse of the given matrix A. Next question. Question 1C, the second part. Use Cramer's rule to solve x1 plus 2x2 is equal to 6, minus 3x1 plus 4x2 minus 6x3 is equal to 30, and the third equation is minus x1 minus 2x2 plus 3x3 is equal to 8. So first of all, try to understand that how we solve a system of linear equations using the Cramer's rule. So first of all, the simple formula that is first of all we have to find the determinant, call it D, in which all the rows are exactly the coefficients of x1 x2 and x3 respectively, the first, second and third row. So you can see the first row is exactly the coefficient of x1 x2 x3 from the first equation. What is our first equation? X1 plus 2 x3 is equal to 6. 6, just forget about the coefficient, whatever the right hand side, x1 plus 2 x3, right. So what is the coefficient of x1 x2 x3 in that equation? 1 0 2. So the first row in D is 1 0 2. The second row is minus 3 4 minus 6 is coming from the second equations. What is our second equation? Minus 3x1 plus 4x2 minus 6x3. So that is minus 3 4 minus 6. Okay, sorry, this is maybe it's plus 6x3. So here minus 3 4 6, and then the third equations, the third row is coming from the third equations, that is minus 1 minus 2 3, right. So first of all you have to find the determinant. This determinant should be the non-zero, should be the non-zero element, then we can use Cramer's rule, otherwise not. So you can see 1. I hope that you know how to find the determinant. Okay, the value of determinant, that is 1 into 4 into 3, 12, minus 6 into minus 2, so 12 plus 12, right? Then this is 0, so plus 2 into 9, sorry, plus 2 into 6, minus 4 into minus 1, so 6 plus 4. Okay, so that is 12 plus 12, 24, plus 6 plus 4, 10 into 2, 20, so 24 plus 20, that is 44. Definitely a non-zero element. Now so the solution is exists, otherwise not. Okay, otherwise we cannot use Cramer's rule to find such equations. We have to use matrix method in that case. Now what is this determinant D1? How we find determinant D1? You can see in determinant D1, remove the first column from the D, and instead of the first column we have to add the coefficient 6, 30 and 8, right? The second and third column are as it is. You can see the first column we are removing from the D, 1 minus 3 minus 1, and instead of that first column we are using this coefficients b1, b2, b3, so that is 6, 30 and 8, so 6, 30 and 8, and find this determinant. Okay, now you can understand that how we find D2 and D3 also. D2, in that D2 we are removing the second column from the D, and instead of second column we add 6, 38, right? The coefficient of right hand side part of these three equations. So find D1. This is 6 into 12 plus 12 plus 2 into 30 into 3. 30 into minus 2, that is minus 60, minus 4 into 8, that is minus 32. So this is 24 into 6, that will become 144, and then minus 60 minus 32, so this is minus 92, and minus 92 into 2 you will get minus 184. So 144 minus 184 is minus 40, correct? Now find D2. What is our D2?